Good evening, YouTube viewers. February 3, 2022, I am here in Los Angeles, California. Okay, I've got a new topic for you guys, for you watching my YouTube channel. My discussion tonight will be integration involving logarithms. We are now through the last time around with the integration by parts. Okay, so my new discussion tonight will be discussion on integrals leading to logarithms. Logarithms, it should be natural logarithm. Okay, let's proceed. We got three formulas under integrals leading to logarithms 3. 1, 2, 3. I will give you the equations, then I will give you the derivations. Okay. Formula number 1. The integral of db over the square root b square plus or minus a square equal to the natural logarithm of the quantity b plus the square root of b square minus a square plus c. They should be plus or minus. Okay, that's formula number 1. Formula number 2, the integral of db over b square minus a square equal to 1 over 2a, the natural logarithm of the quantity v minus a over v plus a plus c. That's formula number 2. Formula number 3, integral of db. It's another variation. A square minus b square equal to 1 over 2a, the natural logarithm of the quantity a plus b over a minus b plus c. Okay? Actually, the right hand side is different for number 2 and 3. This is b minus a, this is a plus b, this is b plus a, and this is a minus b. So, take note of those ones. Okay? So, to study integrals leading to logarithms, natural logarithms, memorize these 3 by heart. Okay? Our mind is full of integration formulas already, so it's up to you guys to insert it in your mind. Okay, let's bring out the derivation. Number 1, we will derive this one. For number 1, we will let y equal to the natural logarithm of b plus the square root of b square minus a square. Okay? Plus or minus. Okay? Take the differential of both sides. We are now, call this deriving the formula. To derive the formula, we will take the differential of both sides. The differential of y is dy equal to the differential of the natural logarithm of b plus the square root of b square minus a square. Plus or minus. Okay? dy now equal to, right hand side, it is under natural logarithm. So, it falls under the integral of 1 over u times du. Right? That is the differential of natural logarithm of u. Okay? You recall that formula? And the value of u is a complicated thing a little bit. It's a sum. The value of u is actually v plus this square root here. So if we follow this 1 over u, it should be 1 over v plus square root of b square minus a square times the differential of u. Sum of several functions. So if we take the differential of b, it will be db. And if we take the differential of this, it falls under the power formula. Okay? Because the square root of this is actually b square plus or minus a square raised to 1/2, right? So if you take the differential, it should be nu raised to n minus 1 times its differential. So it will be 1 half b square minus a square. This is minus a square, okay? 1 half minus 1 is minus 1 half times the differential of the term inside. It should be 2b db. E square, the differential of e square is actually 0. This is actually plus 0. I didn't place it anymore. So I will just simply put 2b db over here. And if we simplify this, okay, there is a common factor db. db, I put it here. Right? No. Oh, it's something like this. If we try to simplify this one, I bring this negative 1 half down. So what will come out is actually these two here cancel with this. So the one that remains on top is just b db all over this square root. First one is 1 times db, it's this. Right? All over this one here, b plus the square root of b square minus a square. Oh, it's just a matter of simplification, okay? The numerator is a fraction, supposed to be the denominator is a fraction. So to combine db and this, we will multiply db by this all over the common db, right? So db times this plus b db all over the common denominator now for the numerator. All over the denominator as a whole is b plus the square root of b square minus a square. Actually, this is what over 1. Okay? We will rewrite the numerator, okay? So to multiply the denominator, we will take its reciprocal. Okay, so we are not violating something. 1 over b plus the square root of b square minus a square. And luckily, this thing here cancel with this. So what will remain on the numerator dy now equal to dv times 1 is just dv. The common denominator, what remains, because we cancel this one, it will just be simply b square minus a square, the square root. We continue here. We will integrate both sides now. The integral of dy, the left hand side, equal to the integral. What remains on the right hand side after the simplification is dv over the square root of b square minus a square. And also we take the integral of that. And we are computing for this. Right? We put it on the left. Equal to, we put this on the right, the integral of dy. But the integral of dy is just y plus c. Right? When the integral sign goes the differential sign, it will cancel out. So actually what remains on the right hand side will just be simply y plus c. But what is y? Y originally is natural logarithm of the quantity b plus the square root of b square minus c square. This is plus or minus. Okay? That's formula number 1. In general, the integral of dv over the square root of b square, sorry for this one, it should be plus or minus. Right? Equal to the natural logarithm of the quantity b plus the square root of b square plus or minus a square plus c. That's formula number 1. Okay? Okay, let's proceed with the derivation of formula number 2. For formula number 2, we will let y equal 1 to 1 over 2a, the natural logarithm of v minus a, v plus a plus c. Take the differential of both sides. The differential of y is just dy. The differential of the right hand side is the differential open quantity. I factor out this one, 1 over 2a. The logarithm of a quotient is a logarithm of the difference, okay? It should be natural logarithm of the numerator minus the natural logarithm of the denominator, okay, plus c. Close bracket, we are taking the differential. dy now equal to 1 over 2a, natural logarithm. 1 over u times du, so 1 over v minus a, okay, times db. dv minus 0, the differential of a is 0, minus 1 over b plus a. We are differentiating this one. 1 over a, b plus a is all over. Times the differential of b plus a, it will just be simply dv. Plus 0, I didn't plus 0 anymore. Okay, this is plus 0. Right? dv now equal to, there is a dv here, there is a dv here, I factor out, I put it outside, all over 2a. What remains on the bracket is 1 over b minus a minus, this is minus, 1 over b plus a. Then we combine these two fractions here. 1 times b plus a is b plus a. Minus 1 times b minus a is actually minus of in quantity, b minus a, all over the product of this. B square minus ba minus ba minus e square. So actually, if we multiply the two denominators, what will come out is b square minus e square. And if we try to simplify this one, this should be b plus a, okay? Minus 1 times b is minus b, minus 1 times minus a plus a. And luckily, this b here cancel with this. Okay? So what remains on the numerator is a plus a is 2a. This will now be 2a. This is 2a, right? And luckily, this 2a here cancel with this. So dy now, I will continue here, is equal to, actually, what I've done here is here. This one cancel with this, okay? So dy now will be dv over b square minus c square. Then take the integral of both sides, okay? Then we rearrange, we are solving for this. Therefore, the integral of dv over b square minus c square equal to the integral of dy, which is equal to y plus c. But what is y? Y is this. Right? Therefore, formula number 2, the integral of dv over b square minus e square equal to 1 over 2a, natural logarithm of the quantity v minus a, v plus a plus c. That's formula number 2. So memorize this by heart and so with this. Okay, let's proceed with formula number 3, the derivation of formula number 3. Formula number 3, we will let y equal to 1 over 2a, the natural logarithm of a plus b over a minus b, okay? Or y equal to 1 over 2a, the logarithm of a quotient is the logarithm of the difference. So it will be the natural logarithm of a plus b minus the natural logarithm of the denominator a minus b. Okay? Taking the differential of both sides, the differential of y is just dy equal to the differential of the right hand side. 2a is a constant, so we could bring it out. So 1 over 2a times the differential of this. They are both under natural logarithm of u equal to du over u. Okay? So the first one, it will be 1 over a plus b, the differential of a is 0, the differential of b is dv, or just simply 1 over a plus b times dv, minus 1 over a minus b, and the differential of a is 0, the differential of minus b is minus dv, it's minus. Right? Simplifying, dy now equal to, I factor out the dv, it's here. So what remains on the bracket is 1 over a plus b. This is minus 1 times minus dv, it's now a plus, right? So this is 1 over a minus b. And if we try to combine these two fractions here, we will multiply 1 by a minus b, it should be a minus b. And we will multiply 1 by a plus b. But anyway, this is plus, actually plus of in quantity a plus b over the product of this is a square minus b square. And if we try to simplify the numerator here, it will be a minus b plus a, okay, plus b all over a square minus b square. Actually, this minus b here cancel with this. Okay? So what remains is actually 2a. So this is now 2a. Okay? So dy now will be the 2b over 2a times 2a. This is the simplification, all over a square minus b square. And this 2a here cancel with this. So what remains is differential y equal to dv over the value a square minus b square. Then take the integral of both sides. Okay? Then rearrange. We put this on the left, we put this on the right. The integral of dv over a square minus b square equal to the integral of dy. The integral of dy is y plus c. But what is y? Y is 1 over 2a, natural logarithm of a plus b over a minus b. So formula number 3, the integral of dv over a square minus b square equal to 1 over 2a, the natural logarithm, okay, of a plus b over a minus b plus c. That's formula number 3. It's easy, guys. So I've given you these three formulas here. I gave you the derivations, okay? So it's up to you guys to insert in your mind these three additional formulas again. Okay, we are running hot. So the next time around, I will be giving you example problems on how to evaluate integrals leading to logarithms, and it is under natural logarithm. Okay? That's it guys for tonight. I hope you are still catching up with me. If you like it, guys, please click like. If you want to share it, please click share. And for those who are taking up integral calculus for the first time, we are running hot, okay? Please click subscribe. Good evening, Los Angeles.